Hello class, it's Mr. Ng, and I figured I'd make a quick video before the night goes out because a bunch of you have been asking questions about the limiting reagents problem set. I know it's coming a little bit late, but this is the best I can do. I hope this helps. So this is the equation within the first part of your problem set. This is and as you can see, it's not balanced, right? Here. There are 3 hydrogens here and only 2 here. That's not balanced. So I think the most common thing that someone would do when they see a 3 and a 2 is to try to get both these hydrogens to 6. So 2 times 3 is 6, and 3 times 2 is 6. Now the hydrogens are balanced. That's pretty good. I have 2 nitrogens and only I have 2 nitrogens here and only 1 nitrogen here. So let's put a 2 in front. Right now I have 2 nitrogens. Now I have 2 O's, right? 2 oxygens and another 3 oxygens. 3 and 2 is 5 oxygens. That poses a problem because look here, O2, a diatomic thing, right? It's got to be an even number, right? I can't put a number here. 2 times something is not going to equal to 5, at least not a real number. So a whole number. So the best thing I could do is I can take all of these and multiply them by 2. So this becomes 4, this becomes 4, this becomes 6. Right? So now I have 6 times 2, I have 12 hydrogens. 4 times 3, I have 12 hydrogens. I have 4 nitrogens, 4 nitrogens. I have 4 oxygens and 6 oxygens. 4 plus 6 is 10. So to get this to be 10, I put a 5 right here, and I am done balancing. Aside from balancing, it's also a good idea to have all of the molar masses. Just do it very quick. I have a periodic table here. I'm going to round like a crazy person just so I could do this quickly. I don't want the video to be too long. So let's find the molar mass of ammonia. It's got 1 nitrogen. Nitrogen has a molar mass of 14. And 3 hydrogens, right? So 3 times 1, right? That's 3 plus 14. So this has a molar mass of 17 grams per mole. And then O2, right? O is right here. It's got a molar mass of 16, right? So 16 times 2 is 32 grams per mole. And then NO, this N, we just saw it. It's got a molar mass of 14 and then a 16. 14 plus 16 is 30 grams per mole. And then water, I think all of us have memorized it by now. Oxygen is 16, hydrogen is 1 each. There's 2 of them, so 2 times 1, and then another 16. So that's 2 plus 16 is 18 grams per mole. Awesome. Hey, let's start going into the actual stoic. So the first part of the problem says that in an experiment, 3.25 grams of ammonia, NH3, are allowed to react with 3.5 grams of O2. So we got to figure out the limiting reagent, the thing that runs out first. To do that, we need to convert all of these into moles and then divide by their coefficients. Here, let's start with 3.25 ammonia on one side, 3.25 grams of ammonia. Right, and on the other side, let's do 3.50 grams of O2. And let's get them into moles, right? Because we know that limiting reagents are determined by their moles, not by their mass. So let's get out of grams. Let's convert from grams into moles. So grams on the bottom, moles on top. Right, and it's for ammonia, NH3, NH3. Notice that I can only change one thing at once. The chemical stays the same, so I could change the unit, right? On those mole-to-mole conversions, like the chemical can change. And we already know that 1 mole of ammonia, look here, is 17 grams. So if I just do a little bit of division, 3.25 divided by 17 is 0.191 moles of NH3. I'm not done yet. I need to divide by the coefficient, and the coefficient here is 4. So I'm going to divide you by 4, divided by 4, and that gives me a number 0.0 0.478. This is the number that I'm going to be comparing the two with to figure out which one's the limiting reagent. I'm not going to use this number, okay? I'm just not going to use it anymore. I saw a lot of you guys using this number later on in your math, and it's a little confusing for you. So don't even touch it. We're just using it to figure out which one is the limiting reagent, okay? And here, let's do the same procedure. So let's convert to moles. So grams on the bottom, moles on top, right? That's how we convert to moles. O2, O2. We already know that 1 mole of O2, look right here, it's 32 grams, 32. So 3.5 divided by 32 is 0.109 moles. And then we still need to divide this by its coefficient, which is 5. All right, divided by 5. And I got 0.0219. So the oxygen is our limiting reagent. So part 1, determine the limiting reagent. It's oxygen. There you go. So easy. For those of you wondering why we divide by the coefficient, well, if you look at the balanced equation, they're not combining on 1-to-1 ratios. So it's unfair to just compare like one whole chunk to the other chunk, right? We need to like consider that it takes 4 ammonias combining with 5 oxygens. So we're kind of dividing them by how many parts how many parts are being contributed there. Okay, so long story short, oxygen is our limiting reagent. That is part A. Next. How many grams of NO are formed, right? Well, we already know that oxygen is our limiting reagent. And if we go back a couple of steps, right, we know that we start with 3.5 grams of oxygen. All right, so let's go with that. 3.50 grams of oxygen. And we want to get to NO. So step 1, like so many other stoic problems in the past, we get out of grams and into moles. All right, that's the only way we could change the chemical, right? So moles of O2, grams of O2. This is exactly like how we did it on the prior page. This is 32, right? 32 grams per mole, right? Now we are in moles of O2. And then we're going to do that tricky mole to mole conversion, mole to mole. When we have a mole to mole, we get to use the balanced equation and we get to switch the chemical. So let's get out of O2. So let's put O2 on the bottom so that it cancels and go to the compound we want, which is NO. Right? And then we got to put in the coefficients. In front of O2, we have a 5. 5. In front of NO, we have a 4. 4. Done. So now we are in moles of NO, and we want to get out of moles and into grams, right? Because that's what the problem wants. The problem wants grams. So to convert that, put moles on the bottom, moles of NO, and then grams of NO on top. And we already know the molar mass of NO, 30. So 1 mole is 30. So now all you got to do is multiply and divide a little. 3.5 divided by 32 times 4 divided by 5 times 30, and I get 2.63 grams. 2.63 grams NO. That's part B. Excellent. And now for the last step, this one kind of goofed us a little bit. How much excess reactant remains after the reaction? The easiest way to do it is to figure out how much ammonia is created. So really, let's figure out, number 1, how much ammonia is not created, consumed. How much NH3 is consumed? All right. So we know we started with 3. I forget. Is it 3.25? 3.5, right? We know that we start with 3.50 grams of O2. And let's try to get to how many grams of NH3 that is. So same old procedure. Let's get out of grams of O2 and into moles of O2, right? 1, and this is 32. And this time my mole to mole, I'm not going to go to NO like I did in the last problem. I'm going to go to ammonia. I want to see how much ammonia was consumed with 3.5 grams of O2, right? So let's put NH3 on top. Let's go to let's get out of O2, right? Moles, O2 moles, right? The good old mole to mole, change of the old chemical conversion factor. And here it's a 4, right? 4 ammonia for every 5 oxygen. Okay? And then let's convert that to grams. So for every 1 mole of NH3, it's a certain amount of grams. I could just look right here. Oh, it's 17. 17 grams of NH3. So let's do a little bit of math. 3.5 divided by 32 times 4 divided by 5 times 17. And what I get is 1.4875. So I'm going to go to sig figs here. So 1.49 grams of NH3. This is how much ammonia was eaten up in the reaction, right? But the reaction started with 3.25 ammonia, right? We started with 3.25 ammonia, and 1.49 got eaten up, minus 1.49 grams of ammonia. Put a little g right here. So now we got to do is subtract, minus 3.25. And we get around 1.76 grams of ammonia left over. And I know you're like, oh, Ing, the answer key doesn't say that. Well, I'm sorry, guys. The answer key was wrong. Don't blame me. I didn't. Don't blame me. Don't be mad at me. But yeah, it's 1.76. Yay. Okay. So there you go. Thank you all for watching. Thanks for all the hard work. I hope this video gets to some of you in time. And I really appreciate you guys being my students. So thank you very much. Have a good night.